Hey, welcome back to Loving the Physics with Mr. Goldthorpe. So we're going to take some time to do some two-dimensional dynamics questions now. So these are big questions, big monsters. And our first one is an object that gets suspended with two strings, as you can see in the diagram here. And we're going to start by drawing a force diagram for this. So of course this object will experience a force of gravity going straight down. So there's your Fg equal to mg. And remember, strings can only pull. So here's the tension force for string 1, call it Ft1. And then string 2, it only pulls, and there's our Ft2. And so this object is what we call suspended. It means it's at rest, staying at rest. And there's going to be two different ways we're going to solve this question. So let me underneath here put method 1. And method 1 is the tail to tip method. And the way we do this one, again, if it's suspended and at rest, staying at rest, which law? And that would be Newton's first law. Now for the tail to tip, all we write is the fact that F net is equal to 0, which means if I add Ft1 plus Ft2 plus Fg, that should become what we call the zero resultant vector. I encourage you to pause and try to draw the tail diagram for this. All right, well, here we go. So we start with Ft1. So here is Ft1. To the tip of that, we add Ft2. And then to the tip of that, we add Fg to get a zero resultant, which means we have to go back to where we started. And there's our Fg equal to mg. And the angle is given to us. That angle right here is 63 degrees. Good. And what we do now is we ignore the equation. We're just going to solve that triangle. That's all we're going to do. And probably a good idea to actually just find Fg. I'm just going to block this part off here. We don't need this anymore. We're just going to be solving that triangle. And I'll tell you what, let me move that down. Just trying to organize my work here. Let's move that down here. I'm just going to calculate Fg above it. All right, so a little bit of a side calculation here. We know that Fg will be equal to mg, and this is a 5 kilogram mass. So 5 times 9.81, which I believe is 49.05 newtons. I'll just double check that. Yeah, that's good. Then I'm going to put that onto the diagram. So there's 49.05 newtons. Okay, so now we can just do some trigonometry to solve for the rest of this question. So if we're going to solve for, let's say, Ft1, then we have opposite and we have hypotenuse. So we know that the sine of 63 degrees will be opposite, which will be 49.05 divided by hypotenuse, which is Ft1. Now if we cross multiply, and then we just get Ft1 by itself. You get 49.05 divided by the sine of 63 degrees. And we know that Ft1 is a hypotenuse, so that should come out to be the longest side. So it better be bigger than 49.05. This one comes out to be 55 newtons. Okay. Now you could do trig as well to find FT2. Or if we add the 55 newtons, this is 55.05 newtons. I'll just show you an alternative technique. Just copy this. Just so you guys have some variety of methods here. We could do Pythag to figure out the last part. So we know that a squared plus b squared is equal to c squared, and c will be the hypotenuse. So we actually end up getting, if you want to call ft2, we can call it a, then a squared plus 49.05 squared will be equal to 55.05 squared. And we end up getting a as being the square root of 55.05 squared minus 49.05 squared. This is another technique you can guys use. And that's about 25 newtons. So that would be FT2. And done. Okay, so this is our first method that we could actually use, is do the tail to tip. But there's a second way. So let me just, if you don't mind, I'm just going to add another page here. Good. Oh, I think I might have put in the wrong location. There we go. Okay. So let's go back to the question here. I'm just going to copy that question one more time. Bring it down to here. Oh, well, okay. Let's not do that. Okay, instead I'm just going to draw the diagram one more time. Okay, so let's just start with method 2. And method 2 is going to be the components technique. So when we have our diagram, there's our 5 kilogram mass, if I remember correctly. And then we have, of course, let's see, we have Fg going straight down. We had Ft1 going this way at an angle, I'll double check this, at 63 degrees. That was good. And then there's our Ft2. And so in this one, what I'm going to recommend you guys start thinking about is, because you have a diagonal force here, Ft1, anytime you see a diagonal force, think components. So I'm going to draw the component diagram for this. This one's going to go up and to the right. And we can just call this y1 and x1. And let's put just a regular reference system on the side here. All right, then what we do in this one is we analyze vertical and horizontal separately. But because we know what Fg is, Fg, if you remember, is 49.05 newtons. Because we know the vertical, we should probably start with the vertical. So we go vertical. And again, this is going to be first law. That means that the sum of all the forces vertically will be equal to 0. And that means the vertical forces kind of cancel each other out. So y1 is positive, Fg is negative, equal to 0, or y1 becomes equal to Fg, and that is equal to 49.05 newtons. All right, now once you've figured that out, you can put that into the triangle here. we now know that this y1 is 49.05 newtons. And that allows us to actually solve that component triangle. So let me just copy that part, and let's solve for that part. And again, I'm just going to add another page because I think I'm going to need it. All right, we're good. So let me just paste that. So we just put this diagram right beside us. Let's solve for what we can solve for. So let's find ft1. And what we'll find out, and I'm just going to do, if you don't mind, a little bit of a quick copy paste here. I mean, I've already done it, so why do it again? Okay, I'm not sure what I did there. Let's try that one more time. Copy that. So the first thing we can do is we can solve for ft1. Okay, and I'm just going to move this up a little bit. Right, and once we have that, then again we could also do, we could find x1, and we've already done that. But I think this one I'll actually do with you. Okay, so we've got that. Now we can find x1, and you can do trig for this one. So if we continue with the trig theme, then we know that x is adjacent, and y1 is opposite, opposite adjacent. So we have the tangent of 63 degrees becomes equal to opposite over adjacent, which is x1. And similar to the previous one, this will come out to be 49.05 divided by the tangent of 63 degrees. Surprise, surprise. That gives us 25 newtons. So I can bring that up to the original diagram, and we'll see that this becomes equal to 25 newtons. I'm just going to take a copy of that so we can finish this question off. So I'll bring that down to here, shrink it down a little bit, bring it to the side. All right, so now that we've done that, we can take this thing on horizontally. So if we go horizontal, or relative to the x, then we know again that F net continues to be 0. All the forces have to cancel out. So x1 is positive, ft2 is negative, equal to 0, which leads to the fact that ft2 must be equal to x1. The two horizontal forces must balance out. And that comes out to be 25 newtons. And we're on our way. Good? So just a summary here. There are two methods we can do for the suspended question. The first one is a tail to tip. And I'll be honest with you, I think the most important thing about this method is, can you draw that triangle? If you can draw the triangle, I'm good. But method 2 is, I think, a better mathematical technique, because this one actually makes more sense. Students really enjoy the idea that if it's at rest and staying at rest, the vertical forces cancel out and the horizontal forces cancel out. It just makes more sense. So I'm going to encourage you to work with the components method as much as you possibly can. All right, why don't you guys give it a try on the homework, and then I'll see you in the next part.